Hello, learners. Hello, grade 10. Um, we thank you for joining us at Age of Life. And today we are going to look at a very interesting topic, which is electric circuits. And I'm going to introduce electric circuits, and then we are going to look at current, and we are also going to look at how to calculate current, and also we are going to look at what is called a series circuit. Right. So our topic is electric circuits. So I'm going to write some few notes for you. Um, Electric circuits. It is a very interesting topic, and it's something that we are going to be doing also in grade 11 and also in grade 12. And for those who are going to be doing electrical engineering, this is your area and you need to master it very well, right from the foundation, right from the beginning. Now, there's a first point that I want to highlight to you, learners. It says electric current flows in a closed system. So it is very important for us to know as learners that electric current only flows, right? It flows in a closed system. Um, should I say closed system or a closed path? Uh, in a closed pathway. Yeah, it sounds much better. So electric current flows in a closed pathway, which means when the pathway is not closed, when it has got gaps, or when there is a switch and the switch is open, current cannot what? Current cannot flow. So it is very important that as we are going to be moving together, we must appreciate the point that electric current flows in a closed pathway. So in bracket, I'm going to say where the switch is closed, right? Where the switch is closed. Maybe someone might be asking, what is a switch? A switch is that component of a circuit which is responsible for closing the circuit and opening the circuit to allow the flow of current when it's closed and to cut off the flow of current when it's open. So electric current will only be able to flow when the switch is closed. That is when the pathway is closed. In other words, current cannot jump a gap. It only flows through a closed pathway. Right. Um, NB, I'm going to put a very important point for you learners here to note as we move forward. It says components. We have got different components in an electric circuit, and we are going to look at them and the different symbols that they use and also their different functions as we move on with our topic. So components can be connected. Components can be connected. Allow me to put mainly resistors inside the bracket, right? So when we determine whether a circuit is a series circuit or it's a parallel circuit, we are looking at the way the resistors are connected. I think for grade 10 level, it is very correct for us to make that conclusion that we look at the way the resistors are connected, and then we can be able to tell whether a particular electric circuit is a series circuit or it's a parallel circuit. Right. So components can be connected in a circuit, right? Can be connected in a circuit in two ways. So this means already we are now having two uh, types of electric circuits that we are going to look at. And we look at the way the resistors are connected. So components can be connected in a circuit in two ways. either in series, right? Either in series, and let me underline the term series, or in parallel, right? So we have got two types of electric circuits. That's what we are getting from that point. We have got a series circuit and we have got a parallel circuit. It all depends on the way the resistors are connected, right? So if the resistors are connected in a series or one after the other, that is a series circuit. And if they are connected side by side, it means that is a parallel what? A parallel circuit. So we are going to look at each type of circuit in detail. But for now, I just want to preempt the lesson and bring to your attention that we have got two types of circuits. We have got what we call a series circuit, and we have got what we call a parallel circuit. Right. Now, the next thing I want us to look at quickly, I'm not going to go deeper into all the components, but I want to highlight the major components that we are going to deal with, and obviously also explain their function and also how these components are connected in a circuit. Right. So I'm going to make a very nice table here. The first column, it has got the name of the component, right? And then the second column, it indicates the symbol of that particular component. And I think that is very important. And then finally, I have got the function of that particular component is the last column. So I'm going to divide my page here into three columns. Uh, and I use a ruler to make sure that I come up with a beautiful table that you guys can see, yes, and appreciate. So that is my table. So I'm going to put the first component that we are going to look at, and then also the second component that we are going to look at. For now, let's look at the first component that we are going to look at. So the first component that we are going to look at, it is the conductor, right? Right from our, should be grade 6 or grade 7, we have been introduced to conductors and insulators. And the definition that we got was a conductor is any material that allows the flow of electric current or the flow of charge, right? And the opposite of a conductor is an insulator. An insulator is a material that does not allow right. So for us to have a working electric circuit, we cannot be dealing with insulators because they won't allow current to flow. So we need what we call a conductor, which is a material which allows the passage or which allows current to flow. So the component that we are looking at is the conductor. The symbol is just a wire. Remember, this mainly we use copper wire. So this is just a wire which is represented by a straight line there. So the function of the conductor is to give way, or it forms the passage for the flow of electric current, or it allows the electric current to flow. So let me just write allows the current to flow. All right, it allows the current to flow. The second symbol that we are going to look at is a cell, right? And the symbol, it has got one terminal which is longer than the other, like that. And the longer terminal represents the positive terminal of the cell, and the shorter terminal, it is the negative what? It is the negative terminal, right? So when it is like this, that is a cell. Now, I want you to appreciate the difference between a cell and a battery. A battery is a combination of many cells, right? But a cell represents one unit, which has got a positive terminal and negative terminal. The positive terminal is the longer one, and the negative terminal is the shorter one. So the electric circuit, the function of the cell in the electric circuit, it is the power supply, right? So it is the power supply. It is the one that pushes the charge to flow right around the electric circuit. Another component that I want us to look at here quickly, which is very important, it is a switch, right? It is a switch, and I'm going to. So the component is a switch. So we have got two ways of representing a switch on an electric circuit, right? The switch can either be open or it can also be closed, right? But what is the main function of a switch in an electric circuit? It is responsible for turning on and off the electric circuit. Remember the previous statement that we made earlier on. We said electric current can only flow in a closed pathway. So what this means is it is the switch which can control whether current must flow or it must not flow. So when the switch is closed, current can flow. When the switch is open, current cannot flow. So I'm going to represent a closed switch here, right? I'm going to represent a closed switch like that, right? This is a closed switch. But allow me also to indicate an open switch. This is an open switch. So we have got a closed switch and an open switch. So when the switch is closed, current can flow. When the switch is open, current cannot flow. So the function of the switch is to turn on and off the circuit, right? Uh-huh. It is responsible for turning on and off the circuit so that current can flow or current can stop to flow. Another component that we must look at, which is also very important in our electric circuits, we cannot move forward without that component. We have a component which is known as a voltmeter, right? Now, what is the symbol for a voltmeter? It is a circle and a V inside. That's a voltmeter. What is the function of a voltmeter? The function of a voltmeter is to measure the potential difference between 2 points, right? It is to measure the potential difference, right, between two points. So our voltmeter, it is connected normally across the battery or the power supply, right? So when it is connected across the battery and the switch is open, so it means that voltmeter is going to measure the total potential energy of the battery, which is called the EMF, right? But when it is connected across the battery and the switch is closed, current is flowing, the voltmeter, it gives us a reading which is slightly lower the EMF. And that reading is known as the terminal potential difference, right? So a voltmeter can be connected across the power supply. Appreciate the term that I'm using here, across the power supply. So it is connected across the battery so that it can measure the potential difference between the two terminals, right? A voltmeter can also be connected across resistors, right? So a voltmeter is always connected. Uh, it is never connected in series, right? Because remember, voltmeter is one of the components on a circuit which has got very high resistance. So when you connect it in series, it means it is going to prohibit, it is going to limit the flow of current because current and resistance are inversely proportional. So a voltmeter has got very high resistance. So it cannot be connected in series. It has to be connected a parallel or across a component, a particular component. Right, we are going to look at that also in detail. And now we are looking at another component which is also very, very important that we need to look at. And that component, it is called an ammeter, right? Now, what is the symbol for an ammeter? It is a capital letter A inside a circle. And what is the function of an ammeter? The function of an ammeter, it is to measure the current, right? So the ammeter is a component of a circuit. It is an instrument that we use to measure the amount of current which flows past through any particular point in an electric circuit. Now, unlike a voltmeter, an ammeter has got very low resistance, which means it allows current to flow through. So ammeter does not interfere with the flow of current because it has got very low resistance. So I want you to take note of the difference between these two instruments here, a voltmeter and an ammeter, right? Number one, a voltmeter is connected across, right? It is not connected in series because voltmeter has got higher resistance. So it must not interfere with the flow of current. An ammeter is connected in series, which means an ammeter is connected along the main line or along the conductor because it must measure the amount of current that flows. And an ammeter has got very low resistance. So in other words, an ammeter allows current to flow. Is that fine? Good. Another component that we are going to look at is what we call a resistor. And remember, resistors are very important to us. And so the common symbol that we use for resistors at this level is that one. Now, what is a resistor? It is a component of a circuit which resists the flow of what? The flow of current. Is that okay? So sometimes our circuits, they don't indicate a resistor. Instead, they put a bulb, right? So a bulb is also a component of a circuit, and this is the symbol that we use to indicate the bulb, right? Another component that we need also that we are going to be dealing with is a variable resistor. Um, we are not going to look at it that much at grade 10, but we need to know it in advance so that when we deal with it in grade 11 and 12, we will be aware of what a variable resistor is. Right. So what is the symbol for a variable resistor? Uh, Slightly different from the normal resistor that you have indicated above. Right. So these are the main components of an electric circuit. We are not going to use all the components in one circuit, but circuits, they vary, they differ, depends on uh, what we want to deal with at that particular time. But I can say in a nutshell, these are the most common components that we deal with when we look at electric circuits. Right. Now, I want to take you quickly to what is called current, and then we look at a series circuit and we do one calculation, and that will mark the end of our presentation. Right. So we need to write the next subtopic, which is current. We have been talking about the flow of current, the flow of charge in a circuit, but we have not defined what is current, what is electric current, right? So we write our subtopic, which is current. So the first thing we need to do is to define what is current, and then how does current flow in an electric circuit, and how do we calculate current in an electric circuit? Good. So the definition for current, it says electric current, right? Electric current is the rate. We are going to underline the term rate, right? It is the rate at which electric charge. It is the rate at which electric charge flows in a second. Right? Flows in a second. So why did we underline the term rate? I want you to appreciate this point that in science, whenever we define something and say it is the rate, it means it is over time, right? So when we say current is the rate at which charge flows in a second, that means current should be equivalent to charge over time, or the amount of charge that flows in a second over time. And our time is supposed to be measured in what? Is supposed to be measured in seconds, right? So this is the definition of electric current that we can always write in case in exam they request for definition for current, right? Another point we need to indicate what is the symbol for current that we are going to be using. We are going to be using capital letter I, that is the symbol for current, and the unit of measurement, the SI unit of measurement for current, it's ampere. It's measured in ampere or capital letter A. Right. So from the definition itself, we can come up with a formula for calculating current, right? If we say current is the rate at which charge flows in a second, so it means current is equals to charge over time because the rate means over time, right? So the formula is current is equals to charge over delta T, which is our time. So we need to label our formula where I represents it represents the current that we are looking at, and it is measured in ampere, right? And Q, it represents the amount of charge that is flowing past a certain point in an electric circuit. And the SI unit for charge is coulombs, right? Remember, we looked at this under electrostatics, right? And our time is time we are going to use the unit of measurement, which is at which is seconds. Is that fine? So this is the formula that we are going to use for calculating current for now, right? Yes. So we need also to highlight. I've got few notes here that we need to highlight under current. Um, Point number one, we need to highlight, let me put a dot here to represent bullet number one. The first point we need to highlight under current, it says current is measured with an ammeter. So which instrument measures the amount of current in a second? It is measured by what we call an ammeter. That one that we have indicated under the table of components, it is there, an ammeter. It has got very low resistance, always connected in series. So current is measured with an ammeter. That's point number one. Current is measured with an ammeter. Current is measured with an ammeter, right? Current is measured with an ammeter. Good. Point number two, or bullet number two, that we must take note of. Point number two, it says an ammeter is always connected in series. All right. I've already explained this point. An ammeter is always, not sometimes, it is always connected in series, right? It is always connected in series. Why does it have to be connected in series? It is because it needs to measure that which flows through a circuit, which is current. And it's easier for an ammeter to be connected in series because remember, it has got an ammeter has got very low resistance, so it is not going to interfere with the amount of current that flows in a particular what second, right? So an ammeter is always connected in series. And another point to support this one, it says an ammeter has a low resistance. An ammeter has a low resistance. An ammeter is a low resistance, so that so that it does not interfere. It does not interfere, all right? It does not interfere with the circuit, or it does not interfere with the flow of current in the circuit. Flow of current in the circuit, all right? So I want to put more emphasis on the difference between an ammeter and a voltmeter. I've seen learners even up to grade 12, they still don't understand why a voltmeter is connected this way and why an ammeter this way. The major difference between these two components, it must be clearly understood at this level. Number one, we said a voltmeter is connected across because it must measure the potential difference between 2 points. And a voltmeter has got very high resistance. So if a voltmeter is connected in series, it is going to interfere with the flow of current, right? So an ammeter now, on the other hand, it is always connected in series because it needs to measure that which flows in the circuit, which is current. And an ammeter has got very low resistance. So in other words, it does not interfere with the flow of what? With the flow of current. So an ammeter is always connected in series. The last point that I want us to look at before we look at an example here, we want to look at the direction of the flow of current in our electric circuit. What is the direction of the current flow in our circuit? Does current flow from the positive terminal of the battery to the negative, or from the negative to the positive? Why am I bringing this issue? Because we have been taught that the normal electron flow must be from the negative to the positive. But now, when we look at the flow of current in our circuit at this level, we are going to use what we call the conventional current. And the conventional current flows from the positive terminal to the negative terminal of the battery. So if you are to draw an electric circuit and indicate the flow of current, you must always remember that we use the conventional current which flows from the positive to the negative terminal. So let me just write that point here. Um, should I put it? Let me write it, I think, as NB so that we don't forget it. So direction, all right, direction of conventional current, right, is from there, is from the positive, is from the positive terminal, is from the positive uh, to the negative, is from the positive to the negative terminal of the battery. Negative terminal of the battery. So as we are going to be looking at the flow of current in our circuits, we are going to be looking at the conventional flow of current. Now, the conventional flow of current says current flows from the positive terminal to the negative terminal of the battery. Right. So quickly, I'm going to do one example for you and show you how to calculate a current using our first formula. Why am I saying our first formula? Because we are going to look at the Ohm's law and we are going to be using it as well to do our calculations on current. Right. Let me just put the formula again on the board so that we can all see the formula. The formula says current is equals to charge over time. Is that okay? And I've already explained that current is measured in ampere, right? And charge is measured in coulombs, and time is measured in seconds, right? So from this formula, I think we can derive another unit for current, right? Because, okay, I'm sure I'm talking to science learners here who can appreciate what I'm going to do here. So current, right, which is measured in ampere, right, is equals to I'm writing the very same formula but using the units. So ampere is equals to your charge is measured in coulomb over your time is measured in seconds, right? So this can be written as coulomb per second. So in other words, I can safely conclude and say 1 ampere is equivalent to 1 coulomb per second, like that. So both units are correct and both units can be used, right? So let me look at example here, and I'm going to calculate it for you. It says how much current, that is the question, how much current, right? How much current uh, is flowing when 10 coulomb of charge, right? 10 coulomb of charge moves past a point past a point in 5 seconds. All right, question mark. That is the question that we have. And now I'm going to provide the solution for that question. Right. What we need to start with is to read and understand the nature of the question. Since I said we can have more than one formula for calculating current, so how do I know the right formula to use? When I look at the formula sheet, I see two, three, or more formulas that I can use to calculate current. So what I need to start with, I need to start with my given data. What is it that has been provided in the question? What am I given? And I call that given data, right? So what am I given in the question? How much current? It means current is our focus. So we don't have it. When 10 coulomb of charge, coulomb is a unit of what? Charge. So it means charge is given is 10 coulomb. And take note, it's already in coulomb, which means no stress there, right? Of converting it from one unit to another. Let's say it was given in nano coulomb. It was going to be stress for us because we're supposed to convert nano coulomb to coulomb. Now it's given in coulomb already, so our charge is fine. And moves past a point in 5 seconds. 5 seconds, that should be time. So we have got time here, which is 5 seconds. So which formula do I have which connect these three variables together? Current, charge, and time. Yes, I do have the formula which says current is equals to charge over time. So current is equals to my charge is 10 over my time it's 5. So therefore current is equals to 2 ampere. Right. Or if you want to use the other units, you can say current is equals to what? 2 coulomb per second. Right. So that is that is the calculation that we have, and that is how we can calculate current. So our current is 2 ampere, and we have used that formula that has assisted us to calculate current. So friends, this is how we calculate current in our electric circuits. And now in our next lesson, we are going to look at what we call a, a series circuit. Now, there are three things that we are going to focus on when we look at a series circuit. We are going to focus on how the resistors are connected, point number one, how do we calculate the total resistance in a series circuit? Then the next thing we look at, how do we calculate voltage or potential difference in a series circuit? And then finally, how does current flow in a series circuit? So that is our next presentation. For now, thank you so much for joining Edge Blush. We wish you all the best in your studies. Thank you.